Have you ever asked an AI a question, but worried it might not have the most up-to-date or specific information? Large language models, or LLMs, are incredibly smart, but they don't know everything, especially about your private data or recent events. That's where Retrieval-Augmented Generation, or RAG, comes in. Think of it like giving an expert an open book to consult before they answer your question. RAG connects the LLM to an external knowledge base, ensuring its answers are not just intelligent, but also accurate, relevant, and based on specific data. So how does this open book system actually work? It's a simple three-step process. First, retrieve. When you ask a question, the RAG system doesn't immediately go to the LLM. Instead, it first searches a specific knowledge base, like your company's internal documents, your personal notes, or a product database, for information relevant to your query. Second, augment. The system takes the relevant information it found and combines it with your original question. This creates a new, much more detailed prompt for the AI. Finally, generate. This enriched prompt is sent to the LLM. With this extra context, the LLM can now generate a precise factual answer based on the provided data, not just its general knowledge. So, to recap, the RAG workflow is: you ask a question, the system retrieves relevant data from a knowledge base, augments your query with that data, and then the LLM generates a grounded, accurate answer. This simple but powerful process makes AI responses much more reliable. But RAG isn't just for answering questions. It's the core of modern AI agents. An AI agent has a goal, like booking a flight. To achieve this, it uses RAG to pull in the necessary information, like real-time flight schedules and prices. This retrieved data informs the agent's reasoning, allowing it to choose the best option and take action, like automatically booking the flight that fits your budget and schedule. RAG gives the agent the knowledge it needs to act intelligently and effectively in the real world. Now, let's show you how RAG works using a code demo.
In this notebook, you will see how you can use RAG using Gemini. First, we build some setup. When the setup is complete, we will go to our first creation of knowledge base. I have chosen some sentence related to RAG as a knowledge base for our RAG model. So we will convert into docs file like doc1, doc2, doc2, doc5. Now we convert those knowledge base into chunks like chunk 1, chunk 2, chunk 3, and each specific chunk is some kind of knowledge. Now let's see, we have to convert it into vector storage, which help us in extracting semantic relation between our question, which is the query, and our chunks, which is our knowledge base. Now, let's let's extract the semantic relation between our query and the knowledge bit without using LLM. I have given a question like what is a RAG and see the nearest semantic relationship between the chunk and the query. Now let's set up the Gemini API. You just have to go to AI Studio and get your API key and now run this cell. When you will run this cell, you will get to how you can configure your API key. You just have to paste it here. Now your Gemini API is set and you can choose these model to run your RAG with LLM. Now let's run our Gemini with our knowledge base. We just have to provide our system instruction and the knowledge base with our LLM. As you can see, I provided it with a chunk, which is our context, and let's see its answer. As you can see, its answer is greatly relevant to the chunk, which is our knowledge base. With this, our RAG using Gemini is over. See you in
If you'd like to explore practical resources and hands-on examples, we've created a dedicated GitHub repository. It's filled with cookbooks covering computer vision, AI agents, and more. Link is in description.